All right, here we go into lesson 5.5, integration with e to the x. What? Yes, you too can integrate with e to the x. And it basically goes with this logic. It's very simple. If the derivative with respect to x of e to the x is itself, then the antiderivative of e to the x is also itself. Of course, plus the constant of integration. And you can check that answer. The derivative of this, well, c goes to 0, and the derivative of e to the x is e to the x. So then the integral of e to the u, the antiderivative of e to the u would be e to the u plus c. And that's just showing you something where if u is, well, a little u substitution involved there, then we'll see that that's going to be the way, and then it's very simple. The integral of e to the x is e to the x, and the derivative of e to the x is e to the x. So another piece of information to just kind of have in the forefront of your mind when you're integrating with e to the x is, since the derivative of functions involving e involve the chain rule and u-substitution, is the reverse chain rule, you better believe that integrals are going to involve u-substitution. So what I'm saying here is the chain rule comes out with e to the stuff, right? E to the stuff, d stuff. And the reverse chain rule is u-substitution. So if we're reversing differentiation, we're going to be using a lot of u-sub. And that's the case, a lot of u-sub here. So e to the 4x, let u equal that exponent. That's not always going to be the case, but often the case will be that the exponent is going to be u. So I'll let u equal 4x. du is therefore equal to 4dx. Well, we don't have a 4dx, so we're going to put a 4 there. And simultaneously, I'll have to divide by 4, or multiply by 1/4. So I get 1/4 times the antiderivative of e to the u du. Now, antiderivative of e to the u is e to the u. So I get 1/4 e to the u plus c. And so we're just going to plug in like we always do. So think normal u substitution with e rules. Very, very straightforward. So that's going to be e to the u, which is 4x plus c. And as always, I'll do it here. I recommend that you check your answer, right? You don't have to do it on every problem, but do it enough times to keep A, fresh on your derivative rules, and B, to see that you integrated correctly. So I highly recommend checking a lot of your answers to accomplish both those goals. So the derivative of this would be 1/4 times e to the stuff d stuff. The 4 and the 1/4 cancel, and you're left with e to the 4x. It's beautiful. Okay, this one here. Well, it looks like the derivative of x to the 5th is right there. In fact, that is perfect e to the u prime. So if you notice that, you could actually say that's your answer. If you happen to notice it, it's e to the minus x to the 5th. If not, that's cool. Let u equal minus x to the 5th. du is equal to minus 5x to the 4th dx. Now from here, I'm going to plug in. Well, minus 5x to the 4th dx is exactly what that is right there. That is du. So we get e to the u, that's u, and du. And the antiderivative of that, it's going to get very boring, e to the u plus c. And that'd be e to the u plus c. There you have it. Not bad at all. Let's go to the next one. Okay, so we're going to end the video after these two problems here, and then we're going to go into some manipulation of some e problems. That'll be exciting. So this says find each integral. Same thing. So first of all, that 4 needs to come to the outside there. And this is actually no different than what we've been doing. We have u substitution and we have e. But in this case, your u value should be that inner function right there. So I'm going to let u equal to 2 minus e to the x. The derivative of that is going to be minus e to the x dx. So we don't have a minus, so I'm going to put a minus here. I'll do that in a different color to set it off. I've got a minus, and then the minus. That cancels each other out. You now have minus e to the x dx. That is du. So minus 4 integral the square root of u du. Okay, now from here, I've got to anti-differentiate. Remember, that's u to the 1/2. Anti-differentiate like normal. Negative 4, that'll be u to the 3/2. If you divide by that 3/2, it's the same as multiplying by 2/3 plus c. And now from here, we have negative 8 over 3. U to the 3/2 is 2 minus e to the x to the 3/2. And if you differentiate that out, you will get back to that right there. It's beautiful. Absolutely beautiful. Okay, last problem. You might see that the derivative of tangent x is secant squared x. Okay, so if you do, you might realize e to the tan x is your answer, like right off the bat, and that's cool if you're there. Totally fine. I'm going to show it with u sub. U is equal to that upper value because its derivative is secant squared x, which is down here on the bottom floor. Du is equal to secant squared x dx. Nice. Okay, well, that is right here. du is in your problem. And so we've got the antiderivative of e to the u. Du is already there. Beautiful. Again, yet another boring e to the u du. We like boring. Well, maybe not love boring, but we can tolerate it. E to the u plus c is the antiderivative. And so that would be e to the u, or e to the tan x plus c. That's it. That's all we've got in this video. So the antiderivative of e, not so bad. In the next video, what we'll be going over is some definite integrals. We'll do that towards the end of the next video. And we'll do some tougher manipulation problems involving e to the x. But you're ready. You've got this. I'll see you there. Peace.